Have you ever wondered why computers cannot use decimal numbers directly? We use the decimal number system every day, with the digits 0 to 9. But computers are different. A computer understands only 2 digits, 0 and 1. That is why every decimal number must first be converted into binary before the computer can process it. So what is the correct answer? Option B. Computers use only zeros and ones. This is because computers are digital devices. They store and process information using only 2 states, represented by 0 and 1. That is why decimal numbers are converted into binary so computers can understand and work with the data. Let's look at the next question. In the repeated division method, what should you do after dividing the decimal number by 2? Take a look at the options. The correct answer is option C. Record the remainder. Every time you divide the number by 2, you will get a quotient and a remainder. The remainder will always be either 0 or 1. Write down each remainder before moving to the next division. For example, when converting 13 into binary, we divide by 2 repeatedly and record every remainder. Finally, read the remainders from bottom to top to get the binary number. A useful exam tip is, always record the remainder immediately after each division. This helps you avoid mistakes and makes the conversion much easier. When using the repeated division method, in which order should the remainders be read? Look carefully at the options. The correct answer is option B, bottom to top. As you divide the decimal number by 2, the remainders are produced from top to bottom. However, to form the correct binary number, you must read the remainders in the reverse order, from the bottom to the top. For example, when converting 13 into binary, the remainders are 1, 0, 1, 1 from bottom to top, giving the binary number 1101. A simple way to remember this is last in, first out. So always read the remainders from bottom to top to get the correct binary answer in your exam. Which binary number represents the decimal value 25? Take a moment to look at the 4 options. The correct answer is option B, 11,001. There are 2 common methods to convert a decimal number into binary. The first is the repeated division method. Keep dividing the number by 2, record each remainder, and finally read the remainders from bottom to top. The second is the binary place value method. Compare the decimal number 25 with the binary place values 16, 8, 4, 2, and 1. Since 25 equals 16 plus 8 plus 1, the binary digits become 1, 1, 0, 0, 1. So, the binary representation of 25 is 11,001. In the exam, you can use either method. Choose the one that you find faster and easier. Which method uses binary place values such as 16, 8, 4, 2, and 1? Take a moment to read the options. The correct answer is option B, binary place value method. This method compares the decimal number with the binary place values, which are powers of 2. For example, to convert the decimal number 19, start with the largest place value, 16. Since 19 is greater than or equal to 16, write 1 and subtract 16. You are left with 3. Next, compare 3 with 8 and 4. It is smaller than both, so write 0 for those positions. Then compare 3 with 2. It fits, so write 1. Finally, compare the remaining 1 with 1, and write 1. The binary number is 10,011. A useful exam tip is, always start with the largest binary place value, and work your way down to 1. This makes the conversion quick and accurate. What is the binary equivalent of the decimal number 42? Take a moment to look at the 4 options. The correct answer is option B, 100,1010. You can solve this question using either of the 2 conversion methods. The first is the repeated division method. Keep dividing 42 by 2, record each remainder, and then read the remainders from bottom to top. The second is the binary place value method. Compare 42 with the binary place values 32, 16, 8, 4, 2, and 1. Since 42 equals 32 plus 8 plus 2, the binary digits become 10, 10, 10. So, the binary representation of 42 is 101,010. Remember, both methods are correct. In the exam, use the one you find faster and more comfortable. Which statement about the binary place value method is true? Take a moment to read the options carefully. The correct answer is option B. It compares the decimal number with binary place values. This method works by comparing the decimal number with the binary place values. 16, 8, 4, 2, and 1, or larger powers of 2 if needed. You always start with the largest place value. If the value fits into the decimal number, write 1. If it does not fit, write 0. Continue this process until you reach the ones place. For example, the decimal number 19 becomes 10,011 in binary. A useful exam tip is, binary place values are powers of 2. Always work from the largest place value down to the smallest, for a quick and accurate conversion. What is a common mistake students make during binary conversion? Take a moment to read the options. The correct answer is option B, forgetting to include leading zeros when required. Leading zeros may not change the value of a binary number, but they are important when a question specifies a fixed number of bits. For example, the binary value for 5 is 101. However, if the question asks for an 8-bit binary number, the correct answer is 0000101. The leading zeros ensure that all 8-bit positions are shown correctly. A useful exam tip is, always check how many bits the question requires. If a fixed bit length is specified, include the necessary leading zeros to match that bit width. If the binary number 101,101 is given, what is its decimal equivalent? Take a moment to look at the options. The correct answer is option C, 45. To convert a binary number into decimal, use the binary place values. Starting from the right, the place values are 1, 2, 4, 8, 16, and 32. Now add only the place values where the binary digit is 1. That gives us 32 plus 8 plus 4 plus 1, which equals 45. So the binary number 101,101 is equal to 45 in decimal. A useful exam tip is, always start from the rightmost bit, where the place value is 2 to the power of 0, or 1. Then move left, adding only the place values where the bit is 1. This makes binary to decimal conversion quick and accurate. If the decimal number is 58, what is its binary equivalent using the repeated division method? Take a moment to look at the options. The correct answer is option A, 111,010. To use the repeated division method, divide the decimal number by 2 again and again. After each division, write down the remainder, which will always be 0 or 1. Continue dividing until the quotient becomes 0. Finally, read the remainders from bottom to top. For the decimal number 58, the remainders produce the binary number 111,010. So 58 in decimal is 111,010 in binary. A useful exam tip is, never stop dividing until the quotient becomes 0. Then remember to read the remainders from bottom to top to get the correct binary answer.